Hello, my name is Daniel, and I'm going to be showing a question about the analysis model of Newton's second law. So in this example, we have one block pushing another. So let's imagine a block 1, so it has mass m1 and the second one has mass m2, and the mass of m1 is greater than the mass of m2 in this case. And then a force is acting on m1 and m1 in turn is pushing m2. So the first question is A, find the magnitude of the acceleration of the system. So I'm just going to add a new page and write this as okay, that's like bigger. Sorry. So M2 has to be smaller than M1. And this is our force acting on M1. Okay, so we know that if the force is acting on M1 and M1 is pushing M2, and please note this, M1 and M2 are in contact. So in contact. So the acceleration of the system will be the sum of masses in the system, which is this whole mass. You can just assume that this is one whole block. So the force will be the mass of the system times the acceleration of the system. So if we want to solve for the acceleration of the system, we just divide both sides by the sum of the masses. So it will be F over M1 plus M2 equals to A. Or you could also write it as A equals to F over M1 plus M2. So yeah, so this will be the acceleration of the whole system. Then the second question was determine the magnitude of the contact force between the two blocks. So the contact force, the contact force between the two blocks. Let's say we have M1 and then smaller M2. Force F is acting on M1, which is pushing M2. There will be a smaller force in here that M2 is exerting on M1, and in turn M1 exerting on M2. And by Newton's third law, if the force that M2 is acting on M1 is 2-1, that's also equal to the force that M1 is acting on M2. At least when we are talking about their magnitudes. So now we are going to be finding the contact force. That's the force that M1 is exerting on M2. Imagine if I'm pushing a ball, then not a ball, maybe a if I'm pushing something, the contact force is going to be me, the force I am exerting on that thing. So we are saying the force M1 1 is exerting on M2 2. Yeah. If we want to find the force acted on M2 by M1, it's going to be the mass of the smaller weight multiplied by its acceleration. So by Newton's second law, summation of all forces acting on an object is the mass of the object times its acceleration. So the acceleration from this part here, A equals to F over M1 plus M2, is acceleration is F over M1 plus M2. So just substitute it here to be M2 times F over M1 plus M2, and we can rewrite that as M2 over M1 plus M2 times F. And so this will be the contact force between M1 and M2. So you notice through this equation that if M1 is much larger than M2, the numerator here will be really small. So we'll have like a small number, let's say delta for the numerator. And while the denominator will be really large, I'll just indicate that the denominator will be really large. And so this expression will be more like 0. So if mass M1 is really big, the contact force between both of them will be near 0. They will be negligible, so to speak. While if mass M2 is much bigger than M1, it will kind of be the opposite, like the other way around. So if M2 is much bigger than M1, we'll have something that's much bigger over M1 is now negligible, so I'll just write the delta here plus something that's much bigger. And since this one is negligible, this over this will just be like approximately 1. And 1 times the force, so P12 will just be, well, will approximately be the force that's acting on M1. And so there are two cases. If M1 is larger, much larger than M2, the contact force will be negligible. But if M2 is much larger than M1, the contact force will be near, like close to the force that was acting on M1 in the first place. So thank you, and that's all for this question. Thank you.